All right, looks like I am recording now. Okay, so the first thing I want to look at, let's title this, put this in your notebook. So we're going to put this as Week 6 quiz review. And we'll date this as November 30th, 2020. Okay, and we'll start off with example 1. Or we'll call it example A, actually. And this is rewriting, what we call this, rational exponents. Rational exponents. And if you guys miss something because the video gets glitchy or something because of the internet, just know I'm going to record this and post it afterwards. So if you miss something, you can go back and look again. Okay, so let's start off with the first one. So example 1. Give you guys a second. I know you guys are writing that down. Here, I'll just write down the example. So it'll be x to the 7 over 3 is the exponent, 7 over 3. Okay, so we want to rewrite this. This is an exponential form where it has the exponent. So we're going to go basically from exponent form to radical form. So that's the idea here. Exponent, exponential. And I'll put kind of like a two-way arrow. When you put two lines and then arrows going both ways, that just means we can go back and forth. We go from that to radical. Okay, so we're jumping back and forth. Okay, because the first question is just going to ask you to rewrite them. And it'll be like choices, like multiple choice, like, hey, which one of these matches up with the original expression? Okay, so remember, to go to radical form, the denominator is going to be your index, and then the base goes on the inside and becomes what's called the radicand. And everything that's here in the base, a lot of times what we do is we put that in parentheses, and then that numerator, the number on top, becomes the exponent of that number inside. And that's it. That's all you do to rewrite it. Okay, as you basically just take the denominator, becomes the index, this number up here, and the numerator becomes that number on the exponent of the number inside. Okay, so now let's say I've got 36 to the negative 1/3. Okay, so now remember, with negative exponents, we don't want those, so we want to turn them into positive. So right now, if I was to put this over 1, all I'm doing is I'm taking this number and bringing it down to the denominator, and now that exponent becomes positive. So now it's 1 over 36 to the 1/3. Okay, so now I'll still keep the 1 on top, but the part on the bottom I'm going to change into radical form just like I did over here. So now I put the radical on the bottom, and that 3 becomes your index. The 36 goes inside, and the exponent is a 1, so I could write 1 here, but because it's just a 1, I don't need to, so I can just leave it like that. Okay? So remember, negative exponents always, if it's already in the denominator, move it up. If it's in the numerator on the top, move it down. Okay, just move it between the two to get them to be positive, whichever way you need to go. Okay, the last one is, let's say we start with radical form, and now we get to go back to exponent form. Okay, so now we just do the reverse. Okay, so the 3x is the base, and notice how this is in parentheses here. So that means that this 7, this exponent, goes to both the 3 and the x. Okay, so there will be one other case where it wouldn't. So now the 3x, I write here, and I'm going to keep that in parentheses. Okay, because this new exponent is going to apply to both the 3 and the x, not just the x itself. Okay, so make sure you put those parentheses. All right, so now remember that the number on the outside was your denominator, the number on the bottom, and the number on the inside, and sorry, that's a 7, by the way, guys, if you couldn't see that, and the number, that becomes the number on the top. Okay, so it's 3x to the 7 over 6. Okay? Let's continue with the next part. Okay, so now this will be example B. And this is going to be all about inverse functions. Inverse functions. Now there's some picture questions in there where it's going to give you a graph. I'm not going to go over those here, but definitely look at your notes and your homework packet as far as the problems where you had to graph the original function versus its inverse and how that's like the reverse of it. Okay, so I'll do like a quick example. I'll just draw like a little sketch of a graph here. So let's say that my original graph was a parabola like that. Okay. Now with inverse functions, when you graph it, it's always a reflection over this line here. And the equation for that line is y equals x. So whenever you graph that inverse, it's basically reflecting over this line. It's like we're flipping it over. So the reflection of that over that line for the parabola would look like this. So let's say we call this one f of x. Then the name for this one, let me go in a little closer so you guys can see that. Focus that up a little bit. So that's f of x there. So the name of this one, we just put the -1 there. That symbolizes inverse of x. So f inverse of x is how you pronounce that. So f -1 of x. Okay. So if you're looking at a graph, you're looking for that. Does it like seem to flip over that line, or did it just kind of flip down or to the left? You want to make sure that the reflection, when it flips, goes over a line like this, over the y equals x line. Okay, so that's what you're looking for when you're looking for those inverse functions. Okay. Okay, so now let's look at actual functions. So I guess we can call that example 1. Okay, so now example 2 is, let's say I start with a function f of x equals x plus 4 over 3. And the question asks you to change this into the inverse function. So we're going to find the inverse function. Okay, so we don't know what that is yet. So the steps that you want to take are you want to look at your function and think to yourself, if I plugged a number in, what would I have to do first? So let's say I plugged in a 2 here, right? What's the first thing I got to do? Well, the first thing I'd have to do is add 4. So that's what I put here is add 4. That's my first step. And this is what you're going to use to basically come up with the inverse function. First I would add 4, and after I did that, then I would divide by 3. Okay, so now with the inverse function, I basically do the opposite of those, what we would call that, operations in reverse. Okay, so first I go to the bottom, my last step, and I say, okay, if I divided by 3, that means the first step in the inverse is to multiply by 3. Okay, and then I go to the next step up. Okay, so if I added by 4 the first time, that means here I would subtract 4. Okay, so now I'm going to use that to construct my inverse function. So the first step in the inverse function is to multiply 3 or multiply 3 times x. Okay, so first I multiply 3 times x and then I subtract 4. So there's my inverse function. Okay, so basically I do everything in reverse. I reverse the order and then do opposites. Okay, so if we make a note over here, reverse the order and then make opposites. I'll put that in a little bubble as like a little note on the side. So it says reverse the order and make opposite. Okay? Let me move this up a little bit. Okay, so I have room in below that. Okay, so let's do that one more time. Okay, so now let's say I've got f of x equals x cubed now minus 5. Same steps. If I plug in a number into x, what's the first thing I would do? I would raise that number to the power of 3, or I would, okay, so I would what would we say, raise, oops, you guys can't see that, raise, sorry, that's raise, R-A-I-S-E, raise to power of 3, okay? And then after that, I would subtract 5. Okay, so now for the inverse function, f inverse, the -1 of x. Okay, so remember you go first to the last step and do the opposite. So the first step was subtract 5, so the first step here will be add 5. And now the opposite of raising something to the power of 3 is to take the root of something. So the opposite of exponents is basically radicals, just like up here. Like when we did put it in the radical form, that's almost like the opposite or inverse function. Okay, so here, instead of raising to the power of 3, we would take the root of that, okay, or use that radical symbol. So I'll just draw this little radical symbol with the index of 3. Okay, so the first step is I would take x and add 5. And then whatever comes from that, I'm going to take the root, the cube root of that. So I basically write the root over the entire x plus 5. Not just the x itself, but both the x and the 5. Okay, so you want it because you're adding the 5, and then on top of that, you're going to take the root of it, or the cube root. Okay? I'm going to pause. Okay, so now I'm going to start with f of x equals x squared plus 3. Okay? Now, what we're going to do is we're going to construct a table of points for the original function and a table of points for what the inverse function would look like. Okay, so I just put a -1 on just a y to kind of signify that that's the inverse. And so the numbers we're going to use are -2, -1, 0, 1, and 2. And it doesn't matter what numbers you start with. I'm just using those. In the quiz, I already give you the x's to start with, and you just have to find the y's. Okay, so you can use Desmos if you want to, or you can just plug all these numbers in and find the y. So I'm going to show you guys real quick how to use Desmos for this case. Okay, so let's go to Desmos. You guys don't need to go there, you can just watch. Okay, so I'm going to show you how Desmos can generate points, because you might have a more complicated function to do this with in the future, so I want to show you guys how to do that. So the first thing I do is I go to this plus button over here, and I ask for a table, all right? Now the only thing I need to change is this part up here where you see the y, where it shows you like the y value of your table, and that I'm actually going to type in the function. Okay, so our function was x squared. So if I need to, I can go ahead to the little keyboard down here for Desmos, click squared, and then put +3. And now what Desmos is giving me this little exclamation point error is because this x needs to match this x. So what I need is actually a sub 1. So all I do is I go right next to the x, like I just did a second ago, and right there I just click 1 right after the x, and then it'll do like a little sub 1. Okay, so once you get that little colored scatter or dot thing there, you know you're ready to go. So now what I do is I just start typing in the x values. So -2, and you can see automatically it spits out the y value. -1 here, and I go down to 0. And what's cool about Desmos, it'll start to recognize what you're doing. So if I just click enter now, it just starts giving me everything. I can just keep clicking enter, and it'll basically give me the y value for every x value. Okay, so basically what I'm going to do in my notes, I'm going to write down these first four numbers here. So right now I'm writing those down: 7, 4, 3, 4, and 7. Okay, so that's all I needed from Desmos. I'm going to switch back to my other camera. Okay. Okay, so now I've got those points, and remember with the inverse function, all you do is you switch these points around because it's a reflection across y equals x, and what that does is it basically just switches these numbers around. So if it was negative 2, 7, I just write 7, negative 2, and then 4, minus 1, then 3 and 0, 4 and 1, 7 and 2. So it's pretty simple. Once you have one table, you can just draw out the points for the other, and boom, you're done. Okay? All right, so that was inverse functions. Zoom out a little bit, just in case you guys are still taking notes there. Okay, and that was it for that one. Okay, so example number 4. And again, if you guys need to stop me, just go ahead and ask questions. Okay, this is going to be logarithms. Logarithms. Just put a I instead of a Y. Not like the musical rhythm, but rhythm with an I. Okay, so this will be kind of some review. And we're talking about going from log form, which is log base b of a equals e. So I want to label these parts. So this is my base. This is my exponent. And this, I like to call it the a value, the answer, some teachers call it. We'll just call it the answer. Some teachers refer to it as that. But in real math, we just call it the a value. Okay, so here we're going to go back and forth from its inverse, which is exponential form. So basically what I do is I take the base, that becomes the base of the number, or of the equation. The e becomes the exponent of that number, and we set that equal to a. So what we're going to be doing is basically going back and forth between log form and exponential. So let's put logarithms and exponential here in the notes. So exponent, you spell exponent and then put I-A-L, exponential. Okay, so for example, I'm just going to do one example here and then we'll be done with notes. Okay, so if I have the log base 6 and my a value is 216 and my e or exponent, it's equal to x. Okay, basically what we're doing is we're solving for x. Like, what is x? Now, yeah, you could just literally type this in a calculator, log base 6 of 216, and boom, you got your answer. Okay, but we're going to do this by hand on paper and work it out by finding a common base. So first, let's put this in exponential form. Okay, so 6 is the base, and x becomes the exponent, and we set that equal to the a value. So what we want to do is find a common base. Now, what I would start with is first look at the 6 and see if 6 will divide into 216, because you might not know if 216 is like a higher power of 6 or not. So what you can do is just take the bigger number and start dividing it by the smaller number. Okay, so that'd be the first step. Okay, so I'm going to take that and divide 216 by 6. Basically, I'm using the birthday cake method or factor tree, whatever you want to do. And I'm going to divide 6 into 216. Well, if I took my calculator out and divided by 6, I would get 36. And I know that if I divide 6 into that, I get 6. And then I would divide 6 one more time, get my candle on the top, or my 1. So I know that 6, if I multiply 6 3 times, it'll get me to 216. So I'm going to rewrite this as 6 to the x equals 6 cubed. Now, if this is 6 cubed, that must mean that 6 to the x, this must be equal to 3. So x must be equal to 3 for those to be equal, so that's pretty much it. So once you get those to be the same base, that's it, and then you just take the exponents and you make them equal to each other. And sometimes that's like actually an equation that you have. Like it might be like 2x equals 3, and now you got to solve it. But in this case, it's just x equals 3, so it's pretty simple. Okay, so those are kind of questions that you guys should expect to see on the quiz. So let me stop the recording.